Okay, good morning, Julia. Let's take a look at your reflections paper and hopefully I can give you some helpful hints to completing this. So each one of the examples that I want to follow kind of mimics what you see in the reflections assignment. So if you look at number one, this first problem that I'm going to show you is going to mimic some of the concepts that are in number one. Does that make sense? So number one that I want to do, so this is not on your reflection assignment, is like analyzing functions based on their powers. So if I look at two functions, f of x equals x to the fourth and f of x equals x squared, which one do you think is going to grow at a faster rate? I hope that makes sense. Like if I were to put in a really large number into this function, and I were into this function, and then I were to put a really large number into this one, kind of the same value, this one would be much larger, right? Even if I manipulate these functions, right? So let's say I look at another x to the fourth function where I add like a 5x cubed, sorry about that, a 5x cubed minus 3x. And if I manipulate this function and I add in like a 6x into that, even when you add in other degrees, what's going to happen is this function, no matter what exists, even if you're taking away a certain number of x's, that fourth power is going to create a function that's going to grow at a much faster rate when you look at larger values. And you can kind of see that in this graph. So those two functions that I just showed you are pictured here. This is obviously the parabola, right? So this is your x squared function. And if you look at it, this red line, which is my x to the fourth function, does have a higher value at certain pieces. Like if I were to look at -5, right? If I were to look at -5, my values for x are much greater than that of the blue function. On the right-hand side, however, before I kind of surpass this, the blue is actually doing a better job than the red function, right? So this blue one is a little bit bigger. But if I were to zoom out, hold on, give me 1 second. If I were, having some technical difficulties. If I were to zoom out, do you see how up here the red function overtakes the blue function? It grows at a much faster rate. So the idea, the concept behind this is whatever your degree is, which is representative by your powers. So this has a degree of 4. I'm going to actually write that down. That might not be something you're familiar with. It's just the highest power that's in your function. And this guy here has a degree of 2. Whoever has the higher degree, eventually it's going to grow at a much faster rate. So that's the concept on number one, and hopefully that can help you when you're looking at your number one. Okay, so the next one I want to look at is talking about functions and whether or not a function is a factor. All right, so I want to look at a function f of x is equal to, I don't know, let's go x to the fourth minus 5x squared, plus 4. Okay, so we're going to take a look at this function and we're going to decide whether or not something is a factor of it. So I could factorize this function. That might be a little bit challenging, but we can definitely look at Desmos and see what the factors are. I wonder if x plus 2 is a factor. I'm just going to pick out another random value. I wonder if x plus 4 is a factor. Okay, so if something is a factor, if a term or a polynomial is a factor of the function, that basically just means that I could take this function, multiply it by another polynomial, and I'm going to achieve the function I started off with. If I can't multiply it by a polynomial, it can't be a factor. And all factors pass through the intercepts that make this function 0. So if I were to look at this, if x plus 2 is a factor, then this graph is going to pass by -2. And if x plus 4 is a factor, then this function is going to pass by -4. You following me? All right, so back up to Desmos. I'll get rid of this guy, and I'm going to change him into x to the 4th. This is just minus 5x squared. So, boop, minus 5x squared, and then plus 4. Plus 4. All right, so here's our function. I'm going to zoom this out so we can kind of see what's happening around the x-intercept. All right, so let's see what we got here. We got, oh, there's a intercept at 2, 0, 1, 0, -1, 0, and 2, 0, or a -2, 0. So my intercepts to this function, and I'm going to just sketch a picture on my paper. You're going to see it in a second. So over here, there's the picture. And remember what my initial question was. Is x plus 2 a factor? Well, because the solution that would make this function equal 0, right? If this would equal 0, would be -2. If there's an intercept at -2, I know that x plus 2 is a factor. And what do you know? It passes through -2. So is x plus 2 a factor? Yes, it is. What about x plus 4? This would have to pass through the 0, -4, and it doesn't. So therefore, this is not a factor. So on this problem, it's asking you in your number 2 problem on your reflection, it's asking you to kind of determine whether or not it's a factor based on the graph. Make sure you answer the question about whether or not it is a factor. So that's a really important thing that I know some kids miss. And then you can also check this to make sure that you're correct by substituting in the solution -2. If I put -2 into this function, f of -2, I should get out a 0 value. Let's see, -2 to the 4th minus 5 times -2 squared plus 4. This is 16. This is going to be 4 times -5 is minus 20 plus 4, and I do get out 0. If you substitute it in and you don't get out 0, then it's not a factor. Making sense? I hope so. So that's number 2. And feel free, as you're going through this, Julia, pause, try the problems that are on here. I know this video is going to be kind of long, but hopefully it will give you places that you can look at. Make notes about the time pace and just kind of be thoughtful about that. All right, so number 3. So this was number 3 in what they're looking at. And what I'm going to say to you about number 3 in this one is there are ways of telling which is the graph without actually graphing it. So without actually putting this into a graphing calculator, you can actually tell which one is which. And this function has a ton of intercepts. There's one at 1, there's one at -8, there's one at -4, there's one at -2, and there's one at +6. And this one, if you look at it, behaves exactly the same way except for here. This has an intercept of 2, while this one has an intercept of -2. So what happens is one of these functions kind of does this, whereas the other one does this. So it based on the loops of the function, it's going to kind of be loopy. We're trying to decide which one does which. And the idea is if you substitute in 0 for your x's, and you figure out what your y-intercept is. What you're going to notice is the y-axis is somewhere over here. And if your y-intercept is negative, you know it's going to be the green function. And if your y-intercept is positive, it's going to be the red function. And this is just because it's really close to your x-axis. Oh, I'm running on low battery. Let's hope I can utilize my last 4%. All right, so consider these functions. Okay, so I think I might discuss with you this one specifically. Take a look at this. 4x plus 3. What would be the solution to 4x plus 3? All right, let's sit here. I'm going to come over here. So 4x plus 3. I want to know what the solution is, meaning where does it equal 0? Minus 3, minus 3. 4x equals negative 3. Divide by 4, divide by 4. X is equal to negative 3/4. Now I want you to notice something here. Would the solution to this portion of my expression be negative 3/4 as well? This idea of factoring, I think I actually want to show you an example of this. Follow along with me. Let's take a look at number 4. All right, so number 4. Imagine for a moment I had the function f of x equals 3x plus 2 times 2x plus 5 times 4x minus 1. And I wanted to know what relationship it had to this function. X plus 2/3, x plus 5/2, and x minus 1/4. Hopefully, as I was writing it, you were noticing some things. The key part that I want you to think about that is if I were to factor out a 3, would I not get x plus 2/3? And here, if I were to factor out a 2, divide 5 by 2, would I not get 5/2? Factor out a 4, I would get 1/4. So I really could write this f of x function as 3 times x plus 2/3, right? Distribute that out. And then 2 times x plus 5/2, and then 4 times x minus 1/4. And I guess I think I chose the same values, but take a look at what we got here. 3 times 2 is 6. 6 times 4 is 24. That would mean that my f of x function is 24 times my g of x function, because these factors really represent g of x. I hope that kind of makes sense to you. All right, so I'm going to move on to the next page, but I'm going to start a new video. So find that.